So good morning, everyone. We're just gonna start in just a couple of seconds. All right. All right, perfect. So let's get started. So today's topic, it's gonna be the telescopic tooling. I don't know if you had a chance to watch the video on YouTube. It was just a kind of like a teaser video, but this is about a specific axis that Oliver is gonna be talking about. So here you can see that's the invitation that you probably saw floating around on LinkedIn. We have Oliver there, his picture. He's actually also online right now on the video. A couple of things that I wanted to mention. Here we go. So you can see Oliver is there. We're also, Alejandro and myself, we're the hosts for this session. And we also wanted to have this picture here so you know how to contact us if you had any further questions after the session, okay? So one thing, we're gonna be recording this session so you can watch it later. If in case that you missed something or you have to jump off the call, you can always watch it later, and you can also check out the email addresses in case that you need to send us something. So Alejandro and Oliver, thank you very much for joining us today. Oliver, I really appreciate your time. You are truly our special guest today. So let's get started.
Okay. Thank you, everyone, and good to be here. So, yeah, so I'm Oliver Fernandez, as Sandro mentioned, and I work for Festo Canada in the Customer Solutions Department. Short background for me, I've been working in the industrial automation field for about the last 15 years, with the last 8 being at Festo. So again, I'm here today to present the telescopic actuator, which was developed here in Festo, Canada. And it has pleased us that it's gathered a lot of interest lately through our social media posts. Yeah, Sandro said it's a teaser, and it was just a casual video we took, and some pictures that we took in our shop. But as I said, we're really pleased. It gathered a lot of attention. It just led to us to thinking that now would be a good time to present this in a little more detail. So. Yeah, next 10 minutes or so, I'm just going to talk about the short background on how this design came to be, top level description of how this works, give you a little rundown on the specs of this tooling, and some future developments that we plan on doing on this tooling.
Oliver, sorry to interrupt you quickly. Sandro, also for the audience right now, remember that you're more than welcome to ask any question. During the presentation or at the end, we're going to stay for a little bit longer than 30 minutes in case you want to rejoin us. In case the meeting ends up after the free Zoom session, then you're more than welcome to reconnect and we will be there for you. And the last thing is questions in English, francés, and español are more than welcome. So, y si tienen alguna pregunta o quieren interrumpir, son más que invitados, ¿ok? Dale, Oliver. Go ahead, Oliver.
All right. Thank you. Alejandro, can you allow me to share my screen?
Oh, sure. Oh, sorry.
Or Sandro,
Yeah. There you go.
All right, gracias. All right, let's see.
You can also see the telescopic tooling in one of the videos that are right now on.
Yeah.
Go ahead, Oliver.
Okay, so this tooling, telescopic tooling, came as a result of a need in an ASRS system, or an automated storage and retrieval system. In a nutshell, just to brief review what that is, it's basically it's a storage system, usually with shelves on the front and the back, and in the middle is your gantry system. And the purpose of the gantry system is to deliver product from one side of a shelf to another, or to reorganize products within its existing shelf, or to transport them, back and forth. Space is at a premium in these type of designs because you want more product in your given space. So a lot of times you don't have a lot of room for a gantry or tooling. So you have to be creative in the way you transport these products. So early on, a couple of years ago, we were approached with this application, a vending machine, and we developed sort of a first telescopic tooling, which was telescopic tooling which went in only in one direction. So it'd go from the middle outwards. We utilized our existing EGC ball screw tooth belt actuators coupled with some mechanical mechanisms. Now this is used in these vending machines that you will have seen in the Toronto Pearson Airport. Next time, whenever that is, you're able to travel. If you see these vending machines, for the source, they dispense electronic components, and you can clearly see. So we were able to show this because there's nothing to hide. You can clearly see our Festo mechanism and this telescopic actuator. You'll see, and it takes one of these products, puts it on the output bin for the consumer.
So one important thing that you have mentioned is that these products, so this first pass, this first version of it was based also on a standard Festo actuator, right?
For sure, yeah. So through the process of these iterative processes, we've always leveraged standard Festo products as the base. And in customer solutions, our role is to use standard products, but customize it or engineering it in a way where we're not limited to just Festo products. We use other third-party mechanisms to create an automated solution that you cannot find in a catalog. So that's a good point. We always leverage existing Festo product.
Yeah, one of the things that we also mention is like the possibility to, instead of using, let's say, Festo motors, you can use anything else. You can use any third-party material motors, which is an advantage because then you have a nice tooling that can be attached to pretty much any motor in the market, and the setup is fairly simple.
Yeah, and we admit that, like, we acknowledge that customers have different specs for their motors, and we're okay with that. We can still support the customer's application. Obviously, we'd like to propose our Festo motors first, but we're open to interfacing with others.
Exactly.
Okay.
So what I have on this screen is our first generation fully telescopic tooling. So it fully goes forwards and backwards, all within this envelope here. We developed this for a pharmaceutical application. We really tried to make it really slim because the shelves were very small and didn't have a lot of room. So this is our first application where we saw the need of having a very slim, low-profile telescopic tooling that could be used in an ASRS system for, and in this case, it was, without revealing too much, it was canisters, plastic canisters of product. The canister was very thin, maybe, 30 mil wide. We designed it to fit within the shelving and to accommodate the product.
So this is one of those other situations where you really want to keep things tight because of the space restrictions, right? I see there you have the dimension for the overall length of the device, which is 364 millimeters. What's how far can it extend? What's the reach?
So in this version, there's a 3-to-1 ratio. So for every millimeter the main EGC axis goes, this top stage would move 3 millimeters.
Oh, wow.
Yeah, so that's the amplification process that we've designed into this.
Okay.
Yeah. So the next iteration we did, it's a variant actually. This was for a heavy duty application. So this one, payload was about 10 kilos. But the product itself was wide. So obviously we couldn't use our previous design, which is very thin. It's thin for a purpose. But we had to accommodate this, which was 200 mil wide maybe, and 10 kilo. So the way we picked up and placed this product was through magnets, permanent magnets embedded within the top stage of this product. And we would pick up from underneath the this tray, this metallic tray. And by removing it, we would strip off the magnet by either lowering from the Z-axis or shearing off with the tooling, the magnets. You can also see this is really a fully integrated solution with sensors and barcode readers. So it's sort of like a smart telescopic actuator. You have sensors to detect the placement of the product within the telescopic tooling. That determines that it's in a safe position for this tooling to move. So it's it prevents crashes and the like. And there's some barcode readers too to detect, to read each of the trays that are in the shelves. So it's great for data tracking as well.
Cool. Do you guys usually use stepper motors or servo motors, or it doesn't really matter?
So let's go back to this one. This one was stepper. Didn't really require a lot of torque or speed. This one was servo because we did need the speed, and this one was servo because it needed the torque and speed. So yeah, in a nutshell, we can use whatever.
Okay.
The application. Obviously, cost is a concern, so steppers you'd use for cost considerations, but depending on whatever the customer needs, we'll adapt.
The other thing also important on this, Oliver, and you probably have it in your mechanical setup, is how you bring all those cables from the tooling back to the main cabinet. And that's also a concern because you have a highest speed telescoping running, or actually flying through a bunch of canisters locations, and then you don't want to have a lot of cables running around. So one of the advantages of using, let's say, like stepper motors or servo motors with a single cable technology is that you can reduce the amount of significantly the amount of cables. And if you put everything on a particular network that allows you to put power over the network, like power over EtherCAT or power over Ethernet IP, then you can minimize the amount of cables going through the tooling.
That's right. Yeah. Cable management is a very important, sometimes forgotten aspect of design for gantries. So that's one of the benefits of this telescopic, because the top stage, as it is right now, we're relying mostly on just mechanics of restraining the product, be it pins, locating pins, or magnets. So on that top stage, you have no moving cables, which eliminates the need for cable track, which makes it a lot cleaner and a lot simpler, which allows us to keep the tooling a little more condensed because we don't have to worry about cable management.
Okay, cool.
Yeah, so that's through those iterations, that led us to develop a quote unquote standard telescopic actuator. Standard in a way that now customers can look at this product and design around this instead of vice versa, where we design to an application. So it just opens us to more customers and more applications where they can see this product. It's already, it's a system. What and you Oliver, get with this is,
Sorry, I was going to ask, and I know that usually and naturally today also we have participants from all around the world. So is this something that customers can buy all around the world?
Yes, for sure. Right now, there's no specific part number for it per se as in a catalog number. We would need quantity for that, but no, for sure. We've already sold a lot of these units, and I'll go into detail to that later. But you go through our customer solutions department, and that's how you purchase it. That's how you purchase a lot of these custom solutions, as the name entails, customer solutions, these custom automated systems through our customer solutions department. All right. And we can provide a quote to you as a system.
Yeah.
Okay.
Just already sold some devices somewhere, Oliver? Do you remember?
Oh yeah. So a lot to the US for medical.
We got some of these in Dubai, I believe, and different areas that we're already.
Right. Yeah, and the vending machines. Yeah. So our end users will send them all over the world, and they are present in many countries, and hopefully we'll see some more as this product gets recognition.
Right. Well, one comment, guys. We're halfway through the session, so just wanted to give you a heads up.
No problem. Thank you. Okay, so now here's the product that you've seen in the videos and in posts. So this is our standard, somewhat standard. It utilizes our ELGC actuator. ELGC, it's a covered ball screw actuator, and the rail is covered with a stainless steel strip. So it's totally enclosed. It's a nice clean looking version. We have our middle stage and our top stage. So at the top level, the way it works is the ELGC base axis drives through a rack and pinion, the middle axis, which then drives the top axis, which is through timing belt and pulley. So the system you would get would be this whole mechanical system with the EMMS ST is our stepper motor, and then also our CMMO stepper drive. So that's what's included. What the customer would be responsible for is the top, so the tooling portion of it. I just gave examples of what we provided in the past: stainless steel bracket with some locating pins, or the embedded magnets.
Right, because we don't really know what the customer is going to be carrying on that axis, right?
We don't know. So yeah, the customer usually has a better gauge of what the product is, and they probably have a better idea of how to handle that. So a lot of times we leave that as a scope to them.
Okay. There's one question in the chat that I already kind of answered, or I just gave a preface there. Mateos is asking about commissioning of the axis inside of the Festo software. So I know Alejandro is going to probably touch a little bit on this, and I just mentioned that, but I just wanted to verbally.
Yeah, so I think when we do the video, I think Alejandro will do a step, walk you through how that's commissioned.
Okay.
So yeah, I'm almost done mechanically. So let's just, I'm gonna go over the specs, just as an FYI. This unit itself weighs about 6.5 kilos, so about 14 pounds. Dimension-wise, it's about 400 mil long, 112 mil high from the base to the top of the top stage, and about 78 mil wide. So the width would be the width of the middle and top stage, which actually would engage within your shelving. Top speed is about 0.8 meters per second. That's driven by the ball screw speed of this ELGC. We did some internal tests for deflection. So we put 10 kilos on the end at fully extended. We saw a deflection of about 1.2 mil. And the repeatability, we measured about plus or minus 0.05 millimeters. And the life we can estimate about 5,000 kilometers, which is correlated to the life of the ELGC actuator, which is what all our actuators are rated to. And we also made a PSI documentation for this, which we can share later
brochure.
Yeah, a little brochure. Yeah, so we can share that at the end too to give you some info. Some developments we're working on, integrating a cable track. So like I mentioned, we're kind of limited to the tooling we have on the top. Yeah, we need just mechanical pins or magnets. But by integrating a small cable track, now we can is to make this tooling way more versatile. We can add some more mechanisms on the top. So I'm going to work on making a vacuum cup module that we can fasten onto the top. Just feed in your vacuum through a generator or vacuum blower. I'm also going to integrate some electromagnets, feed in some 12 volt DC through here. Or recently we partnered with MagSwitch. They have some very unique magnetic actuators, which I'd like to integrate to the top of this telescopic tooling. So that's in the works, something to give variety to this tooling.
Sounds...
And just one thing to add is we're not limited to just that size. We can adapt to your different payloads or different strokes. This is just a starting point that we're presenting. So if you ever have a unique application which falls outside of what we listed in our standard brochure, for sure we can work with you and try to deliver a solution that will work for you.
Cool.
So that's it. So I think I'm going to stop sharing and maybe we can actually look at the real deal.
Yeah, let me make Alejandro Which session, which one is it, Alejandro, the one that you're using? I don't hear you.
I know. Okay, you can pick up
the one where you have the microphone?
Yeah, that one.
Okay.
I'm gonna share my screen over here.
Yeah. There you go. You're now the host, so you should be able to share.
Yep. Okay. So first thing I want to show you guys is a real picture of how the system looks like. In fact, we have this this little screen here. I don't know if you guys can see it. Hold on. New share. This is the one. This one. Okay. So let me know what you guys see. Do you guys see the screen?
Yep.
All right. So this is how the mechanical system looks like in a high density rack. So you can see the amount of areas that you can access from this telescopic tooling. You can see the telescopic tooling all the way down at the bottom of this system. This is a 3-axis system plus the tooling. So, and then this is all controlled over EtherCAD. That's the first portion of the presentation, which is a nice picture of how dense can a system be. And this is how the rack and pinion looks like from the side. And then, of course, this is kind of one of the first systems we built, but it's a demo for demo purposes. Now, let me stop sharing, and I'm going to share now and answer also the question about the Festo automation suite. So it's a fairly simple configuration, actually. So you can do it in multiple ways. We set it up in multiple ways, actually, with the customer. Let's say if the rack and pinion system is a 3-to-1, so you want to know exactly what the position is at the end of arm tooling, then you're going to have a gear ratio of 3-to-1 in your system if you want to move it that way on your configuration. So you can pick up just a standard actuator and then add an additional gear ratio on your FAS. So if you go to the device configuration, then here we have an ELGC bolt screw, and we know that the feed constant for this is 12 millimeters per revolution. So we can have the final configuration for the end of arm tooling set up in 2 ways. One way is you can add an additional gear at the end. This will basically divide or multiply by the gear ratio that you have at the end of the mechanical device, or you can modify the feed constant in this particular axis. It's kind of customized axis that you're going to change the feed constant. So the values that you send over Profinet or EtherCAD or any other platform will match exactly what the end of arm tooling is doing, and not
Alejandro,
necessarily what the first stage. Yeah, go ahead.
One question. If I configure it with the gear, would that also affect the tuning of the motor? I mean, the current gains and
Yes.
all of those things.
Yeah.
So
yes, exactly.
would it be better then to do the feed constant, because that would be only for the distance and it wouldn't affect the closed loop parameters, right?
Yeah, exactly. So it depends, because if you have a mass, let's say this is running on a stepper motor, and then you have a mass that is changing more than 25% from load to load, then you probably want to have a nice tool set up on the tuning area, on the tuning parameters. So your mass won't affect the stepper motor performance. So yeah, you can do it in one way or the other. At the end of the day, we want to move 100 millimeters at the end of arm tooling. You do it one way or the other. And also, some people also do this way. Let's say we installed this system with a backup controller, and this was running on EtherCAD. What they did, instead of touching all these configurations, because you don't want technicians to come and start like thinking how these guys develop this mechanism and what the gear ratio is. So just leave it as a default parameters. And what they did is on the HMI and the software in the background, they just divide it by 3 or multiply by 3 or the gear ratio, and then that's it. So you get technicians on the field, they know the basics. They can just change the axis and that's it. You don't have to worry about it. Yeah, so that's another way. So yeah, if we go to control right now, I have a few record positions here. So let's give it a run. So you guys can see on the screen how the axis is performing. It's a nice setup because you can have multiple ways to control these axes. For example, you can control in torque when you are reaching to a certain level, then you touch, set up the value for that torque, move the axis, and reach whatever you're going to take. So the nice thing about, let's say in this case, using CMMT-ST is that you have a way better options, a much better options to control the axis and have this tooling working for you in a right way. So you can set up on position, force, and any other way. And everything is through, in this case, is an EtherCAD component, but you can run it on Profinet. You can also go in the old way also. The CMMO is still in the market. You can still use it, and you can use the standard CMMO. And the CMMO also has some nice features about force and position and everything else. It's just because when you run on CMMO, let's say this motor, if you guys can see on the screen, you have two cables coming into it. Is not the nicest way to do it, but this is an old demo that we have to show customers. But the new versions that we're building, actually, they're running on single cable technology,
Okay.
which is clearly an advantage for customers.
For
any question?
Yeah, I'll open the questions. I mean, if anyone wants to type a question, well, I'll say this. For those people watching that are not very familiar with the whole Festo portfolio or products, Alejandro mentioned two kind of products. So he mentioned CMMO. CMMO, it's basically a stepper drive. So you can look it up on Google. And then he also mentioned CMMT. So that's also, I mean, CMMT-ST, that's also a stepper drive. So I just wanted to clarify that for anyone that's not very familiar with the Festo lingo. So now,
this is pretty much what I have to say. If there's any question, it will be nice to answer.
Yeah. So now we can see there, and I guess the rest of the participants can see the device there. And I guess we can start talking about the takeaways from this session. We can see there how compact it is. And I don't know, Alejandro, if you can flip it a little bit so we can see it from the other angle, like from the front.
Yep. Sure, 1 second.
Yeah, here we're looking at it from the side. But you can see what Oliver mentioned at the very beginning, that you can move towards the left or towards the right. So it's bidirectional, right? Initially, he mentioned that I guess one of the first versions that were developed was only moving one way, right? Mm-hmm. This one moves both ways. Another takeaway that I take from today's session is that this is perfect for those applications like, for example, ASRS, or automated system retrieval, automated. What is it?
Storage retrieval.
Yeah, automated storage retrieval
systems, I guess.
Yes.
Yep.
Yes.
That's the
Anyways, bunch of shelves. That's what this is for.
Yeah. So it's perfect because now the footprint, it's very small. You can go both ways, so you can have storage on both ways. Oliver showed a very nice example about, for example, a vending machine, but other applications that I've seen is, for example, testing electronic components. I've worked in some applications before, for example, testing hard drives. A lot of the times they have to put the hard drive in one spot, and then they will test it and leave it there, right, for X amount of time. And then they will change it. They will load another hard drive on the other side and then put it there. And now imagine an array of, I don't know, 500 hard drives. So now this tool could be going and picking from there. Another application. Sorry, yeah, go ahead.
No, just quick one. The key is, because it's so slim, that means each row can be closer together, which then increases the density. So that's the benefit of this one.
Yeah.
Right. The other thing is, one of the projects that we built recently was using magnets, as Oliver mentioned. So you don't need to have a particular tool running with the additional cables. In this case, we did a mechanical. How you call that, Oliver? It's a mechanical.
It was just a permanent
mechanism.
magnet.
Yeah, permanent magnet. So that allows you to reduce the amount of cables and so on. I don't know if you guys can see the video I'm broadcasting right now. So you can see the rack and pinion system.
Yeah.
Going through, right? And then at the end of on the end of arm tooling, you have all the setup for the belt that is hitting inside the mechanism.
Nice.
Right. And we also have the homing switch. We did actually a specific bracket that goes inside the mechanism. So this allows you to do the homing, because one of the nice things about this actually is a challenge too, is how you home a mechanical system inside this high density device,
that's
right?
important.
And if you and that's something that we also develop, which is a special bracket that goes in between the rack and pinion and the axis, and has a latch. So these is mechanical, not mechanical moving parts, but is like a sensor and a mechanical latch. So that allows you for how you home it without crashing the axis, for example, going to one end or the other.
So a safe home would be in the middle position, where everything's in the middle.
Yeah.
Because normally if you home to a hard stop, you would be extending or retracting this tooling, which and who knows what's in front.
Main crash can
happen. Yeah. Oliver, we have a question there from Trevor. He's asking about the maximum payload again, so if we can specify.
Yeah, so that one was about 5 kilos, which you see there. Okay. And the reach is about 760, specifically it's 768 millimeters. So from the middle to the end of the telescopic range.
How much was it? Was it 700?
Sorry, that's end to end. 768, but from the
768
middle,
millimeters from end to end.
Yeah, so that's fully extended to fully retracted.
Yeah,
so,
and from the middle,
384.
And from the middle would be
384. Yeah, so half of that.
Okay, 384 from the middle. I'm just typing it here in the chat.
Okay, yeah.
Okay, perfect. I was going to ask another question and now I forgot. We have approximately 6 minutes left for the session. Yeah, we got some questions in the chat. Anyone else that may have some questions, feel free to unmute yourself, or you can just type them in the chat. You're welcome to do that as well. I had another question.
We want to hear voices, guys. Everybody's so quiet.
Right.
We're gonna start singing soon.
I think some people are just shy and they prefer to just type it in the chat. That's fine too.
That's fine. That's fine. That's fine too. This is a nice success. When I remember when we were setting up these, it's really hard to get into the area where the gantry actually is moving. You remember that, right? Like, in order to get into these high density storage systems,
to physically walk in,
physically walking is horrible. So we have to actually move the axis completely out and then set it up out of the gantry or out of the working area and then push it in. Because as Oliver mentioned, is a premium. Like, every spot is really, really hard to get into it, and is also a premium price that you pay for that particular spot. So that's nice. Having this tooling is nice actually, because you can get like very precisely into that particular. And you remember that we have RFIDs. Actually, Sandro, we have RFID readers and writers, because we have to read particular tags inside the system. So we have that in the tooling moving. We also have laser sensors that they don't move with the tooling, but they point towards every side, so we can check when the boxes are there and not there. We can actually read the barcode and so on. So in the systems that we developed before was 2 barcode readers, 2 very precise laser scanners. What was that? The RFID also. Everything was running on EtherCAD, by the way, which is nice. So having the servos, having everything, all the controls on EtherCAD was a nice thing to have.
We have to clarify something though. I mean, we've been talking about EtherCAD, but we can also run Ethernet IP, Profinet, EtherCAD, multiple protocols, right? So we don't want you to go with the wrong impression. The one thing that I was going to mention is the most common industries where I could probably see this being used at is, for example, yes, of course, vending machines, but pharmaceutical, of course. I see this a lot in pharmaceutical and electronics. So as I mentioned, electronics for testing purposes. One other application that I was thinking about that I participated in the past was this customer was building PCs. So they will have these stacks of PCs, and they will, once they finish, they have to test the PC, right? But booting up the PC and going through the video check, USB check, Ethernet connection, that takes some minutes. So they will go and connect. So now imagine that you will have a system like this, and it just connects something, right? It could be something like this as well. So
do you want to show the video, Oliver, or you want me to do it? The high density ASM that we built.
Yeah, I think you have it loaded up. So
okay,
you can
hold on
show
1 second.
that. One thing we also concepted before was this telescopic tooling on AGVs, autonomous guided vehicles. I think that's
AGVs,
what it stands for.
That's a good good example.
I mean, it's all compact, right? So it all fits within the envelope of the AGV, and it'll just go around and pick up bins.
Yeah. I know that you're going to show this video. We have 3 minutes left. So after showing this video, we'll probably wrap it up, and we'll continue talking the next time.
Yep.
So this one's showing the heavy duty one.
Can you guys see the video now?
We see it. Yep.
All right, great. I'm just gonna just go a little bit further. This is one of the high density systems that we built. You can see the size of our racks. And then let me just pause somewhere here.
So that footage you saw was us building it in Festo. So
that's our customer solutions department engineering site. And this is how you can actually see how many tubes we have in one single system. And this is actually nice because you can move tubes from one side to the other. So how many tubes did we have on this one?
Like 200 tubes per tray.
Yeah.
And about 40 trays per side, I believe.
Okay, that's a nice amount of tubes for testing purposes. So this handling system actually runs multiple gantries inside. So we were able to do all the handling for the center, which is moving tubes from one side to the other with the tooling that Oliver developed. But we also have gantries inside doing all the handling for pick and place and moving tubes from one point to the other. You can also see laser sensors, camera systems, everything running all together. And the nice thing about that tooling, which is fairly big, we were able to put all laser sensors, barcode readers, and everything inside.
Nice. Yeah, that's also another very, very important point for these kind of systems, that you want to have traceability, right? Because now you can see these tube is for X patient, this is the sample number X, and this is what we're doing. So you can trace it all through the process from start to the very beginning. So you never lose track of that tube. That's also very important.
Take a look at this. This is what is underneath these tooling. So if you can see it, we have a high precision laser sensor. This is one of the EtherCAD modules for I/O, and we also have barcode readers on the other side.
Yeah.
So
it was a nice, cut off soon, Alejandro. Probably like 30 seconds left.
Yeah, we have like 30 seconds left. But
okay, I'll stop.
Yeah, thank you everyone for joining today. We really appreciate the time, and we'll see you in a couple more weeks. Oliver, appreciate your time, and thank you for joining us as a special guest today.
All right, guys.
Anytime.
Thank you so much. Have a good
day.
Right. Thanks
Bye-bye.
for sharing.
Bye.
Okay, bye.